Hello everyone, welcome to today's lecture. So in today's class, we will solve some previous year questions of JEE on the topic relations and functions. So let us start. The images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. Okay, let us start. Let us start with question number. Let us start with first question. First question says, if the function f is defined from R to R is defined by fx is equal to absolute value of x into x minus sin x, then which of the following statements is true? We basically have to find which of the following statements is true. And the options are f is 1 1, f is not on 2, f is second option is f is on 2, but f is not 1 1. Third option is f is both 1 1 and on 2, and D option is f is neither 1 1 nor on 2. So first we need to know about what is the 1 1 function and what is on 2 function. So we have discussed about 1 1 function and on 2 function. So what is 1 1 function? 1 1 function says, that is, if we draw the graph of fx, then, and if we draw any line parallel to x-axis, then that line must cut the graph on one point only, right? Then the function will be 1 1 function always. And analytically, we can say that if f of x1 is equal to f of x2, right? This imply x1 should be is equal to x2. Then only we can say that the function is 1 1 function, right? 1 1 function. And for onto function, what can we say? Codomain here is R. For onto function, codomain should be equal to range, right? Codomain should be equal to range. Got it? For onto function. Clear? So in this way, you try to think about this question. You have 10 seconds to solve or think about this question. After that, we will discuss the solution part. This question has been asked in JEE Advanced 2020. So you have 10 seconds to solve or think about this question. After that, we will discuss the solution part. Okay, let us move to the solution part. The question was, if the function f from R to R defined by fx is equal to absolute value of x into x minus sin x, then which of the following statements is true? Okay, many are saying option B is correct. Let us see. So option C will be correct answer, right? F is both 1 1 and on 2. Let us check how it is both 1 1 and on 2. See, the given function f is defined from R to R, right? Real to real. So fx is given as absolute value of x into x minus sin x. Let us assume this as equation 1. Since the function f is an odd and continuous function, right? Fx is an odd function and it is continuous. So limit x tending to infinity into fx is equal to infinity, right? You can put the infinity, you will get fx as infinity. And limit x tending to minus infinity, fx is equal to minus infinity, right? Clear? So range will be all real value. Range will be all real value. So we can say that f is onto function, right? So here we can say that f is onto function because range is from minus infinity to infinity. See, fx is basically absolute value of x into x minus sine x, right? First we need to calculate the range of this, right? Range of this. So see, what is f of infinity? F of infinity, that means what will be limit x tending to infinity. So when you'll put infinity in place of x, you will get it as infinity, right? Clear? That is, suppose absolute value of infinity into infinity minus sine infinity, right? See, sine infinity, whatever be the value of value in the domain, it will always be in between -1 to 1, right? And infinity minus -1 to 1 will be infinity, and infinity minus infinity into infinity will be infinity. So it is infinity. Now limit x tending to minus infinity fx, it will be, see, minus infinity mod into minus infinity minus sine x, right? So it will be basically minus infinity, right? Minus infinity. Got it? So you can easily say that the range of function is from minus infinity to infinity, right? The range of function is from minus infinity to infinity. So you can say that the function is onto function, because codomain is equal to range, right? That is, codomain is here. Codomain is all real value, and we are getting range as also minus infinity to infinity, which is all real value. So we can say that codomain is equal to range. So like fx is onto function. Now let us check for one function, right? Now since fx is basically absolute value of x into x minus sine x, so fx can be written as x into x minus sine x when x greater than equal to 0, and it is negative x into x minus sine x when x is less than 0, right? Now let us like differentiate this. See, one condition is also for 1 if any function is strictly increasing or strictly decreasing, then we can say that the function is 1 right? Suppose a function is strictly increasing, suppose this one is strictly increasing, right? So if you draw any if you draw any line parallel to x axis, it will cut the graph only at one point. This is for strictly increasing. Suppose any function is strictly decreasing, right? X is strictly decreasing, then any line if you draw parallel to axis again, it will cut at only one point. So for 1 we can also prove that, like if like a function is strictly increasing or strictly decreasing, right? So how can we prove that function is either strictly increasing or strictly decreasing? We just have to find the f dash x, and if f dash x is greater than 0, then we can say that the function is strictly increasing, and if f dash x is less than 0, then we can say that the function is strictly decreasing, right? So let us move. So fx was this one. Now let us find f dash x. F dash x is 2x minus sin x minus x cos x when x is greater than 0, right? And it is minus 2x plus sin x plus x cos x when x is less than 0, right? So f dash x can be written as, after simplifying and written in the adjusted form, we can write it as x minus sin x plus x times 1 minus cos x, right? When x is greater than 0, and it can be also written as minus x plus sin x minus x into 1 minus cos x when x is less than 0. Since for x greater than 0, x minus sin x, see, for x greater than 0, x minus sin x will always be greater than 0, right? Because sin x will be between -1 to 1, right? -1 to 1 always, and x is like any real value. When x is greater than 0, then we can say that the overall this function is always greater than 0, and x into 1 minus cos x will always be greater than 0. Since x is greater than 0, and like cos x will always be less than 1, right? Cos x will always be less than 1. So overall this function is also greater than 0, right? So we can say that f dash x is greater than 0 for all when x belongs to 0 to infinity, right? For this condition, when x is greater than 0, f dash x is greater than 0 always, right? Because this function is greater than 0 and this function is greater than 0 as well, right? Sir, cos x has come when we have differentiated above function fx, right? The differentiation of sin x is cos x, right? See, we have not removed equality. You can write it. See, you can apply equality either here or here, no problem, right? You can apply equality either here or here, no problem, right? Clear? Okay. So f dash x greater than 0 for all x belongs to 0 to infinity, right? See, generally equality doesn't remove, but like if you like see, the purpose of ours is like to find whether it is strictly increasing or not, right? Clear? So if it is strictly increasing, see, when you apply x greater than 0, sometimes the function looks like this one, right? This one, clear? So when you when you draw any line parallel to x-axis, right? So like sometimes this coincides, right? This coincides. So for that we need to like calculate the function should be strictly increasing, right? Strictly increasing, so that it cut the graph at one point only, right? Okay. So like f dash x greater than 0 for all x belongs to 0 to infinity, right? Therefore f is a strictly increasing function for all x belongs to 0 to infinity, we can say that. Similarly, when x is less than 0, and when you see f dash x, you can see that minus x plus sin x greater than 0 always, right? Because minus x plus sin x greater than 0, and minus x into 1 minus cos x is greater than 0 when x is less than 0. See, x is less than 0, so minus of x will be greater than 0, right? And sin x is always between minus 1 to 1, right? So overall this function will be greater than 0, right? And also this function will always be greater than 0. Clear? As x is less than 0, so this function will be greater than 0, and this function is already greater than 0 because cos x is less than 1 always, right? Clear? So f dash x is greater than 0 for all x belongs to minus infinity to 0 also. So overall we found that f is a strictly increasing function for all x belongs to minus infinity to 0, and we have already found that f is strictly increasing when x is between 0 to infinity also, right? So overall we can say that f is a strictly increasing function for x belongs to all real, right? It implies that f is 1 1 function. So we have proved that f is both 1 1 and onto function, right? Clear? So f is both 1 1 function and onto function. See, when it is easy to draw the graph of function, or when it is easy to differentiate the function, we generally avoid analytical approach, because analytical approach will be helpful for the for algebraic parts only, right? That is x cube, x square, like x. Clear? It will be helpful in that case. But when it is logarithmic, right, sine, cos, like generally analytical approach, do not we do not apply analytical approach, and here it is mixture of algebraic and trigonometric, right? So when you will try to apply analytical approach, you it will give answer on analytical approach also, but you might not reach to the answer by this approach, right? So this is the purpose. So either you use graph when it is easy to draw the graph, or like you can use differentiation also. And when it is directly, suppose you get directly algebraic function, some algebraic function, you can use like analytical approach also, right? That is f of x1 is equal to f of x2. Then you need to solve that, and you need to get x1 is equal to x2 only, right? Okay, so let us move to the next question. Next question says the function f is from 0 to 3 to 1 to 29, defined by fx is equal to 2x cube minus 15x square plus 36x plus 1 is. So the given function from the given domain and range, domain and codomain, defined as fx is equal to 2x cube minus 15x square plus 36x plus 1 is. You need to discuss whether it is 1 1 or on 2 but not 1 1, 1 1 but not on 2, and option D is neither on 1 nor on 2, right? Okay, so Again, you need to know the condition of 1 1 and 2. We know that we either like draw the graph or we use differentiation approach C, and we might use analytical approach also. Clear? And for onto codomain should be equal to range. They see codomain is given as 1 to 29, right? So for this function you need to prove that uh, the range we are getting from this function, either it is equal to codomain or not. If it is equal, then we can say that the function is onto, right? And if it is not equal, we can say that the function is not onto, right? So in this way you can try to approach this question. You have 10 seconds to solve or think about this question. After that we will discuss the solution part. Okay, let us move to the solution part. The function is defined from f 0 to 3, 0 to 3, to 1 to 29, defined by fx is equal to 2x cube minus 5x square minus 15x square plus 36x plus 1. So answer will be B, right? Answer will be B, on two function but not on one function, right? Clear? Answer will be the function is on two function but not one function. Let us see how. To find the range in the given domain A to B, right? To find the range in the given domain A to B, put f dash x equal to 0, right? Put f dash x equal to 0 and find x is equal to alpha 1, alpha 2, alpha n, right? You need to find the roots, right? Belongs to A to B. So let us calculate. Now let us find. So from A to B, we first find all the roots in between A to B, and we can find the values of the given function in between A to B and also at the boundary point, that is A and B also, right? So the least value and the greatest value that you'll get after solving this will be the range of the given function, right? Now f is defined basically from 0 to 3 to 1 to 29, right? And fx is equal to 2x cube minus 15x square plus 36x plus 1. Now f dash x, when you differentiate this, you will get 6x square minus 30x plus 36. So it will be equal to, when you will take 6 as common, you will get 6 times x square minus 5x plus 6. So 6 times x minus 2 into x minus 3, right? 6 times x minus 2 into x minus 3. So when you will see this on number line, it will be plus minus plus, right? It will be plus minus and plus. So for the given domain, that is 0 to 3, fx is increasing as well as decreasing, right? So it is many one, right? So if f dash x would be either greater than 0 or either less than 0 always, then fx should be a 1 function. But you have already seen that it is in some range it is positive, in some range it is negative, right? Clear? It's in some range f dash x is greater than 0, and in some range f dash x is less than 0, right? So you cannot say that the fx is either increasing, either strictly increasing or either strictly decreasing, right? So we can say that the function in the given domain 0 to 3 is many one function, right? Now let us prove is it onto or not. Now put f dash x equal to 0. F dash x equal to 0, we will get x equal to 2 and 3, right? Thus for range, we need to calculate f0. What is f0? See, for the boundary point, f0 is 1, right? When you'll put the value of function like x equal to 0, you'll get f0 is equal to 1. What will get at f2? When x equal to 2, you will get f2 is equal to 29, right? You need to solve this, right? f2 will be 29. And what will be f3? f3 will be 28. You can put the value of 3 here in place of x and find the value of f3. It is 28. So range of the function is, see, minimum value we are getting is 1, and maximum value we are getting as 29. So range of function is basically 1 to 29, right? So range we got is 1 to 29, and you can also see that domain, defined domain is basically defined domain is also from 1 to 29, right? Since the range is equal to codomain, we can say that fx is onto function, right? So fx is not one function, but fx is onto function. Therefore we can say that fx is onto function, but it is not one function, right? Okay, let us move to the next question. Next question says, fx is defined as, next question is, let fx is equal to x if x is rational number and 0 if x is irrational number, right? Fx is x if x is rational number and it is 0 when x is irrational number, right? And gx is defined as, 0 when x is rational number and it is equal to x when x is irrational number. Then we basically have to find we have to conclude about the f minus g, right? What is f minus g? Either it is 1 on 2, neither 1 neither 1 2 into, right? So like we have to calculate about f and f minus g, right? Clear? So this is piecewise function, right? So you can try to calculate f minus g in different conditions, and like try to find whether it is 1 or on 2, right? By using the conditions of 1 and on 2, right? You know the conditions of 1 that it should be either strictly increasing or strictly decreasing. Clear? Or there should not be like two values, there should not be two values of x for a particular value of y, right? For the 1 and for the onto, codomain should be equal to range, right? So in this way you can try to approach this question. You have 10 seconds to solve or think about this question. After that we will discuss the solution part. Okay, many students said about option D. Let us see which option is correct. The question was fx is equal to x if x is rational, and fx is equal to 0 if x is irrational, right? And gx is equal to 0 if x is rational and it is equal to x if x is irrational, right? Then we have to calculate f minus g. So correct answer is option D. Yes, option D is right. The function is both on 1 and on 2. Let us discuss. Let phi x be a function which is equal to fx minus gx, right? Let phi x is equal to fx minus gx. So phi x will be equal to x when x belongs to rational number, and it will be equal to minus x when x does not belongs to rational number, right? Now to check 1 take any straight line parallel to x axis, right? We can draw the graph and check take any straight line parallel to x axis which will intersect the phi x at only one point, right? At only one point, because see, x belongs to rational number, it will be equal to like x something x, right? That is, for a particular rational number there will be a particular value which is x, and when x is not rational number, suppose it is root 2 which is irrational, then we will get fx as, we will get phi x as minus root 2, right? So for a particular value of x, we are getting a particular and unique value of fx, right? Unique value of phi x. Clear? Therefore we can say that phi x is a 1 function. Clear? Now to check onto, what can we do? Phi x is basically x when x belongs to rational number and minus x when x belongs to irrational number, right? So y equal to x and y equal to minus x for rational and irrational values, right? And this implies y belongs to real numbers. So range is equal to codomain here, right? Range is equal to codomain here, because we are getting both irrational number and rational number is range. Clear? So overall range is basically all real numbers, right? So range is equal to codomain. So we can say that the function is both 1 1 and on 2, right? So f minus g is both 1 1 function and on 2 function. Clear? Okay, let us discuss the next question. Next question says, if f is defined from 0 to infinity and fx is defined as x upon 1 plus x, then f is what? We need to discuss about f, whether it is 1 1 and on 2, 1 1 but not on 2, on 2 but not 1 1, neither 1 1 nor on 2, right? What can we do? First, we will try to find 1 1. We will try to check whether it is 1 1 or not. Clear? So you can approach analytical also here, and you can check for f dash x as well for 1 1, right? And for on 2, like codomain given here as 0 to infinity, and you just need to find the value of find the range of the function by taking y is equal to x upon 1 plus x, and after solving and simplification you will get the value of y. All right. So in this way you can try to approach this question. You have 10 seconds to solve or think about this question. After that we will discuss the solution part. Okay, let us move to the solution part. The question was, f is from 0 to infinity and fx is defined as x upon 1 plus x. So correct option is option B, right? Correct option is option B. The function is both 1 1 and on 2. The function is 1 1 but not on 2, right? Function is 1 1 but not on 2. Option B. Let us see. The given function f is defined from 0 to infinity. Here domain is 0 to infinity, right? And codomain is given as 0 to infinity, right? So as to check 1 1, what can we do? Since fx is given as x upon 1 plus x, so f dash x, right? What can we say about f dash x? When we will find f dash x, we can find it as 1 upon 1 plus x whole square, and you can say that it will always be greater than 0, right? Because the square of any number will always be greater than 0, right? So f dash x greater than 0 for all x belongs to 0 to infinity, right? Therefore we can say that fx is increasing in its domain, right? Right? So fx is increasing in its domain. Thus we can say that fx is 1 1 in its domain, right? So we have checked the 1 1 condition. Let us check for on 2. So for on 2, see codomain we are given. We just need to find the range. So let us find the range of the function. Again, y is equal to fx, and it is written as x upon 1 plus x. When you solve this by cross multiplication, you will get y plus yx is equal to x, right? Y plus yx is equal to x. Now x, after solving this, you will get x is equal to y upon 1 minus y, right? Y upon 1 minus y. So since x is greater than equal to 0, by using domain, you can say that y upon 1 minus y is greater than equal to 0, right? Therefore, what you will get when you solve this, that is y upon 1 minus y is greater than equal to 0. So after solving this, you will get y is between 0 to 1, right? Y is between 0 to 1. But see, range of the function is between 0 to 1. But the codomain given is 0 to infinity. So codomain here is not equal to range, right? That is, range is not equal to codomain here. So we can easily say that fx is like 1 1 but not on 2, right? Because it is satisfying the condition of 1 1, but it is not satisfying the condition of on 2. Clear? Okay, let us move to the next question. This question says, let function f from R to R be defined by fx is equal to 2x plus sin x for all x belongs to real. then f is, we need to discuss about the fx, right? Option A is 1 1 and on 2. Option B is 1 1 but not on 2. Option C is 1 1 but not 1 to 1, right? On 2 but not 1 to 1. And option D is neither 1 1 nor on 2. Clear? Again, you need to apply the condition of 1 1 and on 2, right? Fx is given, it is defined from R to R, that is codomain is also given, which is R. We need to find the range, and we need to compare whether range is equal to codomain or not, right? Okay, so many students saying A is correct answer. Let us see. You have 10 seconds to solve or think about this question. After that, we will discuss the solution part. Okay, let us move to the solution part. So the question was, let the function f is from R to R be defined by fx is equal to 2x plus sin x for x belongs to real. Then f is, we need to talk about the f. So correct answer is A, right? Everyone was right. Correct answer is A, which is f is 1 1 and on 2. Let us check. Given fx is equal to 2x plus sin x, right? Fx is given as equal to 2x plus sin x. So f dash x we can write it as f dash x is equal to 2 plus cos x, right? F dash x will be equal to 2 plus cos x. So we can write f dash x. We can say that f dash x will always be greater than 0 for all x belongs to real, because cos x will always be between 0 to minus 1 to 1, right? Cos x will always be between minus 1 to 1, right? So if cos x between minus 1 to 1, you can say that 2 plus cos x, that is, if you will take minimum value also, minus 1, 2 minus 1 is 1, right? So we can say that f dash x is always greater than 0 for all x belongs to real, right? Which shows that fx is 1 1, as fx is strictly increasing, because f dash x is greater than 0 always. Clear? Since fx is increasing for every x belongs to real, therefore since fx is increasing for every x belongs to real, therefore fx takes all the intermediate values between minus 1 to between minus infinity to infinity, right? So range of fx will be all real value. So we can say that fx is on 2. So we can overall we can say that fx is both 1 1 and on 2 function, right? So A option will be correct one. Okay, let us move to the next question. Next question is, suppose fx is equal to x plus 1 whole square for x greater than equal to minus 1, and gx is the function whose graph is the reflection of the graph of fx with respect to the line y equal to x. Then gx is equal to, we need to find the value of gx, and all the options are given. Minus of root x minus 1 when x is greater than equal to 0, 1 upon x plus 1 whole square when x is greater than minus 1, root over x plus 1 when x is greater than equal to minus 1, and root over x minus 1 when x is greater than equal to 0. So you need to basically find the gx, and gx is what? It is the reflection of the graph of fx with respect to line y equal to x, right? So see, any line which is the reflection, any function which is the reflection about any function with respect to the line y equal to x, how can you find it? You can just put the value of x, you can just put the value of x in place of y and the value of y in place of x, right? Clear? So in this way you can try to think about this question. You have 10 seconds to solve or think about this question. After that we will discuss the solution part. Okay, let us move to the solution part. The question was, suppose fx is equal to x plus 1 whole square for x greater than equal to -1, if gx is the function whose graph is the reflection of graph of fx with respect to y equal to x, then gx is equal to, let us find. Option D is correct one, right? Option D is correct one. Yes, you said correct. It is basically inverse function, right? So fx was basically equal to x plus 1 whole square when x is greater than equal to -1, right? It was defined as this. If gx is the reflection of fx in the line y equal to x, then it can be obtained by interchanging x and y, right, in fx. Clear? If like you have to find any function which is a reflection of suppose fx, then what can you do? You'll interchange x and y, right, with respect to line y equal to x, right? So y is equal to x plus 1 whole square changes to what we have done. In place of y we have written x, and in place of x we have written y, right? So x will be equal to y plus 1 whole square, right? Clear? X will be equal to y plus 1 whole square. Now let's find the value of y in terms of x. So we can write y plus 1 is equal to root over x. Clear? Y plus 1 will not be equal to minus of root over x, because y is greater than equal to -1 always, right? So y will be equal to root over x minus 1 for all x greater than equal to 0. Therefore option D will be the correct option, right? Okay, let us move to the next question. You can see the graph of the function also. See, our function was x plus 1 whole square, right? Y is equal to x plus 1 whole square, and we need to draw the graph of function x equal to y plus 1 whole square, which is the reflection of the given function y equal to x plus 1 whole square with respect to line y equal to x, right? So this is the graph of fx and gx. Clear? So therefore gx will be equal to root over x minus 1 for all x greater than equal to 0, right? Okay. So let us see the next question, which says, let E be a set defined as 1, 2, 3, 4 and F be a set defined as 1, 2. Then the number of onto functions from E to F is, we need to find the number of onto functions from E to F. And the options are A option 14, option B 16, option C 12 and option D 8. Clear? So we need to find number of onto functions from E to F, right? So you have 10 seconds to solve or think about this question. After that we will discuss the solution part. Okay, let us move to the solution part. The question was, let E, set E was defined as 1, 2, 3, 4 and F is defined as 1, 2, then the number of onto functions from E to F is. So correct answer is option A, which is 14. We need to find the number of onto functions from E, which is 1, 2, 3, 4 and to F, which is 1, 2. So number of onto functions will be equal to total number of functions or maps defined from E to F minus number of functions for the map for which the map fx equal to 1 and fx equal to 2 for all x belongs to E. That is C. E is 1, 2, 3, 4 and F is basically 1, 2. Clear? Right. So we need to find number of onto functions. So onto function is basically codomain should be equal to range, right? Clear? So codomain is given as 1, 2. So that function will be onto function only when this codomain will convert to range, right? So total number of functions defined from E to F will be 2 to the power 4, right? 2 to the power 4. And we will subtract that function which is into. Into function means all the functions, suppose all the function is connected to 1 only, right? 1 only. So in this case, you will not get codomain is equal to range, right? So one is this case and other is case like 1, 2, 3, 4, right? And suppose 1, 2, 1, 2. All the elements are connected to 2 only. So for these two cases, you will not get the function as onto function, right? Because it is into function, because here codomain is not equal to range, right? So like total number of functions, like number of onto functions will be equal to total number of functions minus number of functions for which fx equal to 1 and fx equal to 2 only. So total number of onto function will be 2 to the power 4 minus 2, which is equal to 14. Got it? So number of onto function will be equal to 14. Therefore option A is correct answer, right? Okay, let us move to the next question. Next question says, let fx be defined for all x greater than 0 and be continuous. Let fx satisfies f of x by y is equal to fx minus fy for all xy and fe is equal to 1. Then which option is correct? That is, fx is bounded, f of 1 by x tending to 0 as x tending to 0, x fx x into fx tending to 1 as x tending to 0, and D option is fx is equal to ln x, right? Fx is equal to ln x. So you need to find which option is correct, right? Okay. So you have 10 seconds to solve or think about this question. After that, we will discuss the solution part. Okay, let us move to the solution part. The question was, let fx be defined for all x greater than 0 and be continuous. Let fx is defined as f of 1 by x is equal to fx minus fy for all xy. Then f and fe is equal to 1. Then option is correct. Option is option D, which is fx is equal to ln x, right? See, fx is continuous and defined for all x greater than 0, right? And f of x by y is equal to f of x minus f of y, and fe is equal to 1. See, it is satisfying all the properties of fx is equal to ln x, right? Because ln x is also like ln x upon y, we can write it as ln x minus ln y, right? So it is completely observable, clear. And f of e, that is ln e, is 1 also, right? Clearly fx is equal to ln x satisfy all these properties, right? Therefore we can say that fx is equal to ln x. Got it? Okay, let us move to the next question. This question says, let set A is equal to 2, 3, 6, 8, 9, 11 and set B is equal to 1, 4, 5, 10, 15. You don't need to recognize all the basic functions. You need to just see whether any function is satisfying this property or not, right? It is completely visible, right? So let set A is 2, 3, 6, 8, 9, 11 and set B is 1, 4, 5, 10, 15. Let R be a relation on A to B defined by AB related to CD if and only if 3AD minus 7BC is an even integer, right? Then the relation R is. Options are an equivalence relation, reflexive but not symmetric, transitive but not symmetric, reflexive and symmetric but not transitive, right? So you have 10 seconds to solve or think about this question. After that, we will discuss the solution part. Okay, let us move to the solution part. The question is, we have a set A which is having elements 2, 3, 6, 8, 9, 11, and set B 1, 4, 5, 10, 15. Let R be a relation on A to be defined by AB related to CD. If and only if 3AD minus 7BC is an even integer, then the relation R is. Option D will be correct answer. Reflexive and symmetric but not transitive, right? It is reflexive and symmetric but not transitive. Let us see. See, we have set A has 2, 3, 6, 8, 9, 11, and set B has 1, 4, 5, 10, 11. And the relation is AB related to CD as one and only when 3AD minus 7BC is equal to even. So let us check for reflexive. For reflexive, here AB is related to CD. So for reflexive, AB must be related to itself, that is AB, right? AB should be related to AB only. So 3AB minus 7AB, which is equal to minus 4AB, and minus 4AB is even itself, right? So it is reflexive. Hence AB is related to AB itself. So it is reflexive. Now let us check for symmetric. Let AB related to CD. If AB related to CD, then we can see that 3AD minus 7BC will be equal to even, right? Because AB is related to CD. This is possible when either both 3AD and 7BC are even or both are odd, right? Because sum of either two even numbers is even, or difference of either two even number is even, or difference or sum of either two odd number is odd, right? This cannot be possible that one number is even and one number is odd, right? Yes, 3, let us see. So if 3AD and 7BC both are odd, right? Both are odd. Suppose odd minus odd even, then both AD and BC are odd, right? Then both AD and BC are odd, right? Case 2, if 3AD and 7BC both are even, that is even minus is even minus even is even, then both AD and BC are even. In both the cases, 3BC minus 7AD will be equal to even, right? 3BC minus 7AD will be equal to even. That is, CD is related to AB also, right? So we have considered that AB is related to CD, and we have proved that CD is related to AB. So we can say that CD is related to AB if AB is related to CD. So we can say that therefore the relation is symmetric also, right? So we have proved that relation is reflexive, relation is symmetric, right? Let us check for transitivity. See, for transitive, let us take example 3, 4 related to 6, 4, right? Let us take example 3, 4 related to 6, 4. So you can write 3 into 3 into 4 minus 7 into 4 into 6 equal to 36 minus 168, which after solving you will get minus 132, which is even, right? So 3, 4 related to 6, 4, and 6, 4 related to 3, 1, right? 6, 4 related to 3, 1 as 3 into 6 into 1 minus 7 into 4 into 3, which is 18 minus 84, which is equal to minus 66, and it is also coming out to even, right? So 3, 4 is related to 6, 4, and 6, 4 related to 3, 1. Then for transitivity, 3, 4 should be related to 3, 1, right? 3, 4 should be related to 3, 1. So let us check whether it is related or not. But 3, 4 is not related to 3, 1, as 3 into 3 into 1 minus 7 into 4 into 3 is equal to 9 minus 34 is equal to minus 75, which is not even, which is odd, right? So we can say that it is not transitive, right? So the given function is reflexive and symmetric, but it is not transitive. Got it? Hence, the relation is reflexive and symmetric, but it is not transitive. Okay. Let us move to the next question. This question says let fx is equal to minus a if x is between minus a to 0, and x plus a if x is between 0 to a, where a is greater than 0, and gx is equal to f of mod x minus mod of fx upon 2. Then the function g from minus a to a is, which one is correct? 1 1, this function is 1 1, like 1 1 on 2, both 1 1 and on 2, neither 1 1 nor on 2, right? You need to discuss about g, either it is 1 1 on 2, right? You need to discuss about. So you have 10 seconds to solve or think about this question. After that we will discuss the solution. Okay, let us move to the solution part. The question was, let fx is equal to minus a if x is between minus a to 0, and it is x plus a when x is between 0 to a, where a is greater than 0, and gx is equal to f of mod x minus mod fx upon 2. Then the function g from minus a to minus a to a is. So option D will be the right answer, neither 1 1 nor 1 2. Let us see. We are given a function fx is equal to minus a when x is between minus a to 0, and x plus a when x is between 0 to a. So gx can be written as f of mod x minus mod of fx upon 2. So what will be f of mod x? F of mod x will be minus a, f of mod x will be minus a if mod x is between minus a to 0, that is mod x is equal to 0, and it will be equal to minus mod x, it will be equal to mod x plus a if mod x is between 0 to a. So f of mod x, we can write it as minus a if mod x is equal to 0, and mod x plus a if mod x is between 0 to a. Therefore f of mod x is equal to minus a if x is equal to 0, right? Minus a if x is equal to 0, and minus x plus a if x is between minus a to 0, and x plus a if x is between 0 to a, right? So now let us calculate mod of fx. So mod of fx we can calculate as, like, mod of minus a is a when x is between minus a to 0, and mod of x plus a is x plus a when x is between 0 to a, right? So gx is basically f of mod x minus mod fx upon 2. So after solving this, we will get gx as minus x by 2 when x is between minus a to 0, minus a when x is equal to 0, and 0 when x is between 0 to a. So we can draw the graph of gx as minus x by 2 when x is between minus a to 0, and it is equal to 0, it is equal to minus a at x equal to 0, it is equal to minus a, right? And it is like equal to 0 when it is equal to 0 when x is between 0 to a, right? Here it is discontinuous function actually. So this is the graph of gx. So from the graph we can say that for x is between 0 to a, the graph cuts the x-axis infinitely many times. So it is not 1 1, right? It is not 1 1. Now for on 2 we see that the domain, the codomain of the function is minus a to a, right? Codomain is function is minus a to a, but from the graph the range of the function is, see, from minus a to, from 0 to minus 0 to a by 2, 0 to a by 2, 0 to a by 2, and union minus a, right? Minus a is also there, right? 0 to a by 2 union minus a. So you can easily observe that codomain is not equal to range here. Hence the gx is neither 1 1 nor 1 2. Clear? Codomain is not equal to range here, so you can say that gx is like neither 1 1 nor 1 2. Clear? Okay, let us move to the next question. This question says, let GIF t be the greatest integer less than or equal to t. Let a be the set of all prime factors of 2 3 1 0, and f, a function f is defined from a to z. B, the function fx is equal to log 2 x square plus greatest integer of x cube upon 5, then the number of one to one function from a to the range of f is. We basically have to find the number of one to one function from a to the range of f is. The options are 20, 25, 24, 120. So you have 10 seconds to solve or think about this question. After that, we will discuss the solution part. Okay, let us move to the solution part. The question is given here. So correct answer is option B, which is 120, right? So let us see. See, prime factors of 2, 3, 1, 0 will be 2 into 3 into 5 into 7 into 11, right? All the odd number, 2 into 3 into 5 into 7 into 11. Clear? So the prime factors is 2, 3, 5, 7, 11. Therefore, fx is equal to greatest integer function of log 2 x square plus greatest integer function of x cube upon 3, which is given, right? The function f is defined from a to z, right? So put the values of x and find the values of fx, right? You need to put the values of x and find the values of fx, right? Since the box is the greatest integer function, we know. So the number of one to one function will be how much? 5p5, right? 5p5, because like for each prime factor we will get a particular value of fx, right? So like there were 5 prime factors, so for each prime factor we will get a particular value of fx. Clear? So like all the 5 values are connected to all the 5 values, so there will be 5p5 number of one to one function, which is equal to 120. Got it? Okay, let us move to the next question. This question says, let A is defined as 1, 2, 3, 4, 5, and let R be a relation on A defined by x related to y if and only if 4x less than equal to 5y. Let M be the number of elements in R, and let N be the minimum number of elements from A into A that are required to be added to R to make it symmetric relation. Then M plus N is equal to, we need to find the M plus N, and the options are 26, 23, 24 and 25. Clear? You have 10 seconds to solve or think about this question. After that, we will discuss the solution part. Okay, let us move to the solution part. Yes, option D is the right answer. Option D, 25 will be the right answer. M plus N will be equal to 25. Let us see. See, the given set A has 1, 2, 3, 4, 5, right? The relation R on A is defined as x related to y if and only if 4x less than equal to 5y. Now for x equal to 1, suppose if you put x equal to 1, you will get y greater than equal to 4 by 5. If x equal to 2, you will get y greater than equal to 8 by 5, and so on for different values of x. So all the relations you will get R as 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, right? 2, 2, 2, 3, 2, 4, 2, 5, 3, 3, 3, 4, 3, 5, 4, 4, 4, 5, 5, 4, right? And 5, 5. Got it? So the number of elements in R is M, which is equal to 16, right? Now for R to be symmetric, we will have to add for 1, 2 we need to add 2, 1, right? Because we need to make it symmetric, right? For 1, 3 we need to add 3, 1. For 1, 4 we need to add 4, 1, right? For 1, 5 we need to add 5, 1. For 2, 3 we need to add 3, 2. Got it? For 2, 4 we need to add 4, 2. Like for 2, 5 we need to add 5, 2. For 3 4 we need to add 4 3. For 3 5 we need to add 5 3. Hence we need to add 9 relations to R to make it symmetric, right? So n is equal to 9. We need to find m plus n, which is equal to 16 plus 9, which is equal to 25, right? Clear? So 25 is the right answer. Got it? Okay, thank you so much.